This session, we're going to look at things from a little bit of a different perspective. This time we're going to talk about augmented reality and, more importantly, how to use augmented reality to visualize information really, really effectively. And in particular, how to create a digital twin of the farm. And we'll talk a little bit about what digital twin is as well. But first, let's just start with these pictures here. And every one of these pictures has got something very much in common. In all of these pictures, we see people interacting with the digital world. They are interacting with things, interacting with data, processes, whatever, in a digital world, but not one of those people is sitting at a computer behind a desk. And we kind of know this, right? We kind of know this because this is the world we live in. But if you think about that, this is really powerful because 20 years ago, the only way, or even 10 years ago really, the main way that we interacted with digital world was outside of the real world. It was conducted at a desk with a computer in front of us. Now, most of our interactions are occurring in the physical world, and the digital information is connected to the digital world somehow, and increasingly we want to see that digital information in the context of the physical world. So this is what we mean when we say that digital and physical worlds are combining and being connected. And we also talk about automation and the role that has on people's jobs and roles. And even this guy, even his job may not be safe from automation because, hey, someone's invented a digital dog. And it's kind of funny to think about, but what we're seeing is that more and more machines are being used which are connected to the internet. So these machines are instrumented, they have measurements coming off them all the time, they are generating data, and we want to do something with this information, and we want to use that digital information. Some digital trends that are obviously very, very important, and we'll talk about in a moment how they all connect up together, but clearly augmented reality and virtual reality is important as a method of visualizing and displaying things, displaying information. Well, that's unfortunate. The Internet of Things is where we connect a machine up to the internet and then we can get all the data off the machine. We can measure what it's doing. We know exactly what it's doing at any time. Data analytics is obviously where we can analyse the data and we can help a human make the best possible decision from the information that is available. And then artificial intelligence and machine learning, because we're now generating so much data so quickly that it is not possible for a human to actually make those decisions fast enough. So we need the machine learning in there to make the decisions very, very fast because a human can't do it. Now, that all makes sense, but how do you link all these things together? How do you link all these concepts together? And what is the technology that makes all that happen? And that's what we call digital twin. Digital twin is usually defined as being able to creating a virtual representation of a physical asset, a physical system, or a physical process. That's all it is. But it's very, very, very powerful technology and very, very powerful concept. That means that an asset could well be a piece of farm equipment, a tractor, it could be a pump, it could be in a food processing, it could be some machinery in a food processing line. A system would be an entire factory. It might be an entire meat processing plant, or it might be a dairy production plant. And process could well be the process of doing the maintenance on the equipment. It could be the laboratory quality control processes. It could be the logistic processes that take the produce from the farm all the way through to an end customer. So these are processes, and what we want to do is we want to create a digital model of all of these things entwined and collect the data and then make use of it. Now, when we do that, why do we do that? Well, we can predict what is going to happen next much more effectively. We could simulate what would happen if you made some kind of a change. And really, really importantly, we want to be able to make people understand what is going on. And this is the visualization part. And this is really where augmented reality and virtual reality come in, because we can create that immersive display of what's happening physically. We can do it at an off-site location. We can have somebody walking through the dairy processing plant and actually seeing what's happening to the machines as they walk through it, and any combination therein as well. Let's give an example of where this is actually happening. So We're doing this, we did this last year actually with a mining services company. They have drill rigs that they operate for the mining companies. Heavy equipment, it's remote locations, and when it breaks it's really expensive. It's not just expensive from the maintenance perspective, but it's the lost productivity that really costs the money. And the equipment is instrumented. It's fairly advanced equipment. Already has sensors on board to measure temperatures and pressures and exhaust temperatures. Everything you can imagine is actually being measured by the machine. But if I'm standing next to the machine, I don't know what's going on inside that machine. It's measuring it. I could come in and plug a dongle in and collect the information off it. But if I stand next to the machine, I don't actually know the state of the machine. The operator in the cabin has a little bit more information. They've got some dials that tell them a little bit about what's going on. And they have alarms that go off. Now, the challenge here was that you'd think that when the alarm goes off, you'd be able to tell the supervisor, and the supervisor will be able to dial in for maintenance. They'd be able to fix it. What was actually happening was the operators were silencing the alarms, and when I say silence the alarm, I mean they were actually reaching under the cabin, pulling the cable out of the alarm speakers, so they didn't have to listen to the annoying beeping noise. So the alarms weren't coming off the machines, they weren't getting actioned, the machines were failing, and it was generally a catastrophic failure rather than a small preventative maintenance activity that could have been performed, costing very large amounts of money. So what we did is they wanted to be able to see what was going on in the machine, and the first part of this was to collect the information off the machine through Internet of Things. So we connected the machine to the internet. It wasn't very difficult. We got the information back. We created a mobile app, like an app on an iPhone. The supervisor can move the phone over the entire mine site, and wherever there is one of their mining machines in operation, they can see the information live about what that machine is doing at that point in time. Very useful. They go right up close to the machine, they're standing right next to it, they can point the iPhone at the machine, and they can see exactly which part of the machine is faulted. They can see that it's the exhaust manifold that's gone over temperature, or they can see that there's too much pressure in the hydraulic system, or whatever it might be. It highlights in red, they can see which part of the machine, additional information. Also goes back to the maintenance planners, who are located in one of the capital cities. They have that information instantly available. But then what they wanted to do, they wanted to take this one step further. They wanted to see what was the future like, and could this actually be done with a head-mounted wearable at the same time. So we used the daiquiri glasses, and we have the daiquiri glasses at our booth. It's around next to the bus. We used the daiquiri glasses, which is one of the augmented reality head-mounted devices, because it's one of the more rugged, industrialised ones. And the supervisors can put this on in the mining pit and look around at the machine, and they can actually visualise what's going on with the machine live while they're standing next to it. So they can see, it's kind of like seeing through the machine and seeing all the data sensors that are on the machine, but actually seeing it live. Now, the only way to do that before was literally to plug something in while the machine was turned off. So extraordinary capability. Now, a couple of things though. And by the way, this is what the mobile phone app looked like as well. A couple of things though. The big learning from the company, it wasn't actually that hard to create the visualisation. That was actually the easy part. What was a lot more challenging was creating that digital twin, that proper digital representation. And we're now going through with them and doing a much more industrialised version that enables them to scale this at a full enterprise scale to collect the information. So let's talk about creating digital twins for a moment, because that's actually the hardest part in all of this. Now, agriculture's been using drones for quite a few years. Very useful, all sorts of things you can do it, everything from detecting pests and weeds through to when crops are ripening, counting or estimating crop yields, all sorts of things already in use. But let's talk about it in a different context. Let's talk about using the drones to create a digital model of the farm itself. What we're doing is we're actually using drones to build three-dimensional maps of areas. We'll show this in a moment. And doing this at high speed in the field, and then being able to connect those three-dimensional models with all the information that might be being collected and is being stored in the digital twin. So we can use the drones to generate the three-dimensional visualizations and integrate all sorts of data sources into there and do this at speed and in the field. So we'll show this now in the context of, again, a different mining company. Okay, so there's a bit of music that normally goes on the back of this, but I'll talk over it. So drone taking off. Drone is doing the survey, and this is a fairly consumer-grade drone. It's nothing particularly exotic. It's all the camera sensor really that's what's important. We're digitising the information that comes off the drone, and we're doing this very close to real time. So we're not actually relying on the Google Maps type mapping that is already there. We're actually doing this live and building this in real time. We can do very, very large areas. What you saw here is an entire mine site in Western Australian iron ore mine. The area was done probably about 1 kilometre by 1.5 kilometres. Then now visualising that, in this case on a Microsoft HoloLens, so using the HoloLens to create that visualisation. And then we started to combine all the other information that was available. So the mine already had a lot of information. They already had production dashboards about what was going on. So taking that production information that's live and integrating it in there so that we can create a visualisation of what's happening live at that moment in time, and then starting to hook in other sources of information, right? Because we've got mobile equipment, heavy mobile equipment, trucks and other sorts of things. In the previous example, we saw how another company was able to take the live information off their drills. Here we're taking information about trucks and so on, things like what are the work orders that are outstanding on the equipment, what are they doing at any point in time, and being able to integrate that in there as well. And the reason for this is so that we can start making better operational decisions at a time and place and communicate what those decisions should be to people. So this type of technology is also being used in other applications. You're seeing here in mining. It's also being used in other applications in Australia at the moment. But the key here is how do we connect? Key message, how do you connect the difficulty is not in the visualisation. The visualisation is actually relatively easy. There is a significant amount of infrastructure that has to sit behind these solutions, though, to be able to connect up the Internet of Things correctly to create that digital twin. So the key to success here is actually in the digital twin itself. The visualisation is very important because that's where we make the use of the data. Thank you very much.